Okay, so we continued the rest of Pascal's triangle, and we got to row 7. Row 7 being the coefficients 1, 6, 15, 20, 15, 6, and 1.
Right.
And that is essentially our power 6. Now, like we talked about, those are going to be all of our coefficients. So we're going to jump down the page a little here. And we'll take our first term being 4x and negative y, our second term. So first term is 4x, and the second term in the binomial is, what do we say, negative y?
Mm-hmm.
Okay, negative y. So these will be all of our coefficients. So what we're going to do is we're going to set them up like that, this being the coefficient multiplying by the first term. Now, like we talked about, because this was to the power of 6, our first term, when we start off, is going to be 4. And we don't just take x. We actually take 4x to the power of 6. And then our second term, our negative y, is to the power of 0. Okay? Power of 0 we know does nothing for us, but that's fine. We're going to continue with that. We're then going to add our next coefficient. So first one was 1. Our next coefficient, I guess we can do those in blue so that we can see it different, is going to be the value of 6. From there, we have 4x. What power will this one be to?
5.
5, exactly. And now this one, our negative y, is going to be to
1.
1. Now, see, this is where we start to get negative terms.
Okay.
We're always going to add in between, but because this is a negative to the power of 1, it's going to have a negative value. So essentially, this is going to end up being a negative term in the end, because we're multiplying a negative by what's going to be a positive and a positive. So that is what gives us those negative terms. So we don't actually have to memorize the pattern to it as much as we just have to know that we apply the second term to the exponents.
Okay.
Okay. So with that reasoning, our next one being 15, right? So we're going to add and multiply by 15. See, the problem with binomial theorem is it can get very long. This becomes 4x cubed, right? This becomes negative y squared. Now, the reason the pattern switches going from a negative to the positive is because, for instance, what is negative y squared? Do you know off the top of your head?
No.
Well, what is a negative times a negative?
1.
Oh, well, is it a positive? That's what we're looking for. So because that's a positive, we're going to be looking at a positive times a positive times a positive. So that's going to stay positive. And that's where we get that flipping of negatives and positives. It really has to do on whether it's an even exponent or an odd exponent.
Okay.
That's what's telling us. So we continue this pattern out. We're going to write it out. I'm just not going to spend as much time talking there. So we got 20, and then we'll have 4x, 6, 5. This should have been to the power of 4. This is to the power of 3, negative y to the power of 3. I guess we're going to have to continue this on to the next line here. 20, 15 is our next term. Okay. Do you want to read them to me so that I know you know how to spell this out? Sure.
So 15 times 4x to the power of 2 now.
Yep.
And then negative y times 4.
Good.
So then it's add 6.
Yep, good.
Times 4x to the power of 1.
Yep.
So you don't actually have to write it in.
Yeah, that's right.
Times negative y to the power of 5.
Uh-huh.
And then plus 1 times negative y to the power of 6.
Good. We don't have to really write in the 0, right? Power of 6. Okay. So now with that being said, we actually have to find out what that exponent is. For instance, 1 is just going to be the value of 1. So our next line is going to read 1 times, well, 4 to the power of 6. 4 to the 6th. 4,096. So we get 1 times 4,096x.
Okay.
All right? The y becomes 1. So essentially that's 4,096x. Do I have to write that 1 in, or are you okay with it?
I'm okay with it.
Okay, so let's just rewrite that as 4,096x. That's our first term. So we've done the first term here. You can kind of like almost cancel that out if you want to say. Now the next one, plus 4 to the power of 5. And then once we do that, we're going to have to multiply by the coefficient 6.
Okay.
Okay, so that's how we're going to figure out the coefficient for each of the terms. Calculator, where are you? Okay, so again, 4 to the power of 5, 1,024, times 6. So 6114 is our coefficient. 61, I think it's 44, not 1. Yeah. I said that a little backwards. And then it's still x to the power of 5 because we cannot simplify that. And now the y, now because the y is a negative and it's to the power of 1, it's technically times negative y. So we still write the y in, but that negative gets applied to the coefficient. Okay? So this is no longer a positive, it's a negative term.
Okay, to make it the next one the positive.
Yeah, and that's
Okay.
what the pattern is. Did you understand that step I did there?
Yeah.
Yeah? Okay. So then the next one, we're looking at 15 times 4 to the power of 4. And because of BEDMAS, we always do the exponents first, right? Now, what we really should be focusing on is before I even add a positive or negative, I should look at my y value because it's a negative.
Mm-hmm.
Because it's squared, it's going to give me y squared, and it's going to be positive. So I know I'm going to have a positive answer. We should
Okay.
try to work with that one first. Then we're going to have 4 to the power of 4 times 15. Okay, so 4 to the 4th equals times 15, 3,840. So positive 3,840. We still have x to the power of 4, but this time we have y squared.
Okay.
And we continue that pattern. Do you want to try the next one?
Okay.
So what would the next term
So, because it's negative y to the power of 3 becomes positive, so we should put in negative.
be? Okay, good.
And then it becomes 4 to the power of 3 times 20.
4 to the power of 3 times 20. So what do we get?
1280x.
1280. So we get 1280.
X to the power of 3.
Yeah.
And then plus y.
We don't add. It's still multiplied.
Okay.
So because they're brackets together, everything's being multiplied together.
Okay.
So it's still x cubed and then becomes y cubed.
Okay.
That negative just came to the front because when you multiply, think of it like this. If we had -1 times -1 times
it's still
-1,
going to be negative.
it's still going to be give us a negative answer. So
Yeah.
that's why we get our negative here.
Yeah.
So let's continue to the next part of this. These do seem to be rather long. What's the next part?
So it's y to the power of 4, so it's positive, so we can just
Good.
leave it as a positive.
Good.
So it's 4 to the power of 2,
Okay, which is
which is 16,
good.
times 15. So 240.
Good.
X to the power of 2, and y to the power of 4.
Excellent.
And then 4 to the power of 1 is 4,
Mhm.
times 6 is 28. No, 26. 24.
Yeah, that's okay.
Times negative.
It's right. It's going to be a
It's
negative.
negative times y to the power of 5.
Okay, what's my x value?
Your x value is 1.
Yeah, so x to the power of 1
Okay.
and y to the power of
5.
5. Good. And then finally,
It's plus y to the power of 6.
y to the power of 6. That's it. Okay. Does that make sense how to set this up?
Yeah.
So once you have the coefficients using Pascal's triangle, you still have to apply the powers if the terms aren't ones. For instance, this coefficient was a 4. So it does change the coefficients. They won't always be exactly what Pascal's triangle is.
Okay.
Okay? Does that make sense?
Yeah, that makes sense.
Okay, so expanding again, binomial theorem. We have discussion here, and they want us to expand using Pascal's triangle. So personally, I find it easiest if on the side I actually draw out Pascal's triangle and then work with those coefficients. Okay. So since Pascal's triangle isn't the hardest to duplicate, this being our row 1. Okay. And again, because we're a binomial, this is where you think of your AB to the power of 1. Okay. Even though this is row 2. So since we're to the power of 6, what row do we need to get to?
7.
That's right. We need to get to row 7 here. So we have 2. I'm going to squeeze this in. 3, 4, 5, 6, and 7. Now, instead of wasting time showing you all this, I'm going to pause while we do that, and then we'll kind of go from there.